It's a pleasure to be with you. The title of this session is Environmental Public Health Practice, Part 7, Hazardous Chemicals. There are no disclosures for this presentation. Objectives include review the hazardous substances priority list, review key pesticide definitions, review key chemicals from the 4 major classes of organic pesticides, review key herbicides and defoliants, discuss polychlorinated biphenyls, PCBs, organic solvents, and key chemicals used to make plastics. Hazardous chemicals are necessary for modern life, but are also potential health risks globally. Chemicals are ubiquitous in our environment. For example, a cup of coffee contains more than 1,000 chemicals. Advantages of chemicals include their use by farms and ranches to produce food. Chemicals are also used to produce clothing, phones, computers, building materials, rugs, myriad household items, etc. In 1918, the United States produced 10 million pounds of synthetic chemicals, increasing to more than 300 billion pounds per year in the past decade. Disadvantages of chemicals includes proven and potential health hazards, for example, cancer, decreased fertility, adverse birth outcomes, autism, etc., and the threat of chemical weapons. The Agency for Toxic Substances and Disease Registry, ATSDR, and the Environmental Protection Agency, EPA, develops a rank order list of hazardous substances as required by CERCLA, the Comprehensive Environmental Response, Compensation, and Liability Act, that are commonly found at U.S. sites on the National Priorities List, NPL. The National Priorities List is a roster of sites across the United States and its territories that are considered national priorities due to known or threatened releases of hazardous substances, pollutants, or contaminants. The Hazardous Substances Priority List is revised every 2 years with an informal review resulting in minor revisions annually. The rank of this list is determined by a score utilizing algorithm scores that consider 3 components: frequency of occurrence at NPL sites, toxicity, and potential for human exposure at NPL sites. The Environmental Protection Agency, EPA, uses the NPL and the Hazardous Substance Priority List to guide further investigations and determine which sites require remedial action through the Superfund Amendments and Reauthorization Act, SARA. The Hazardous Substance Priority List is not a rank of the most toxic substances, but a priority based on potential for toxic human exposures at NPL sites. There are a total of 275 substances on that list. This table lists the top 20. Notice that 14 of those substances are chemical compounds. This table lists some of the common uses of some of those chemicals. Vinyl chloride is used to produce plastic products, including pipes, wire and cable coatings, and packaging materials. Polychlorinated biphenyls and Aerochlor 1260, 1254, and 1242 are used in electric cable insulation and transformers. The aerochlors are additionally used in hydraulic fluids and manufacture of plastics and pesticides. Benzene is used as a solvent of plastics and in fuels. Polycyclic aromatic hydrocarbons, including benzofluoranthene and dibenzoanthracene, are not used commercially, but are the result of combustion of petroleum-based chemicals and other organic substances. Chloroform, was formerly used as an anesthetic and now used to manufacture other chemicals. DDT was formerly used as an insecticide, but was outlawed in the US in 1972. Trichloroethylene is a solvent. Dieldrin is used as a pesticide. Let's consider pesticides for a few minutes. According to the U.S. Department of Agriculture, pesticides are a vital input in today's agriculture, protecting food and fiber from damage by insects, weeds, diseases, nematodes, and rodents. It's estimated that each dollar invested in pesticide control returns approximately $4 in crops saved. U.S. farmers' expenditures on pesticides are about 4 to 5% of total farm production costs. A significant question for environmental policy in the United States is how should society regulate pesticide use to ensure a bountiful harvest of diverse crops that is needed for a healthy diet, while at the same time making sure that pesticide uses do not have adverse effects on health. Let's consider a few helpful pesticide definitions. A pesticide is a substance or mixture used to prevent, destroy, repel, or mitigate a pest. The term pest includes insects, rodents, weeds, and a host of other unwanted organisms. Insecticides, herbicides, fungicides, nematicides, rodenticides, and fumigants are all pesticides. An insecticide is used to kill or prevent the growth of insects. A herbicide to control or destroy plants, weeds, or grasses. A fungicide to control, deter, or destroy fungi. A nematicide to kill worms or nematodes. A rodenticide to destroy rodents like rats, mice, moles, etc. A fumigant is a vaporized pesticide used to kill pests in enclosed places like greenhouses, other buildings, and soil. Initial pesticides consisted of inorganic chemicals and compounds of sulfur, zinc, copper, mercury, lead, arsenic, and boric acid to control insects, and they were not very effective. In the mid-1900s, neuroactive insecticide compounds were discovered, including chlorinated hydrocarbons, organophosphates, methylcarbamates, and pyrethroids. In the mid-1900s, the use of dichlorodiphenyl trichloroethane, DDT, seemed to usher in a victory over harmful insects. Yet DDT was restricted for use in the United States in 1972 due to concerns about environmental and health impacts. There are several classes of pesticides, including inorganic and organic chemicals. Four major classes of pesticides are organic chemicals, including organophosphates, organocarbamates, organochlorides, and pyrethroids. Organophosphates are a group of major pesticides used in agriculture since they do not persist in the environment. Organophosphates are the most common pesticides causing poisoning and death. Carbamates, like organophosphates, do not persist in the environment and rarely cause poisoning. The organochlorines persist in the environment and are generally banned in the United States. Pyrethrins come from a natural source and are thus called botanicals. Pyrethrins control insects and have low toxicity for mammals. Organophosphates are anticholinesterases that inhibit the transmission of nerve impulses in pests, other animals, and humans. Organophosphates are also called nerve gases and include sarin, soman, and tabun. In 1995, a cult leader released sarin gas into the Tokyo subway system during morning rush hour. 12 people died and 5,500 were injured. Examples of organophosphates include diazinon, malathion, methylparathione, and parathione, administered in a variety of ways. For example, sprays, foggers, flea collars, pet shampoos, animal dips, etc. Some organophosphates, for example malathione, are approved for direct application to food crops, for example apples, grapes, tomatoes, etc. It's always good to wash these fruits and vegetables before consumption. Diazinon is banned in the U.S. due to its toxicity to wildlife and is classified as a Category 1 pesticide. The EPA classifies pesticide toxicity into 4 categories. Category 1 is highly toxic and severely irritating. Category 2 is moderately toxic and moderately irritating. Category 3 is slightly toxic and slightly irritating. Category 4 is practically non-toxic and not an irritant. Diazinon is a Category 1 pesticide. The use of organophosphates has declined in the 21st century due to the availability of less toxic alternatives. Advantages of organophosphates include that they are inexpensive and control a wide range of insects. Many organophosphates do not persist in the environment, and they have not been shown to create insect resistance. Acute poisoning causes malfunction of nerves and muscles, resulting in respiratory paralysis, seizures, abdominal cramping, and in extreme cases, death. Long-term exposure may cause organophosphate polyneuropathy, which presents with numbness, sensory loss, and weakness. These symptoms and signs are considered irreversible. Carbamates, like organophosphates, dissipate quickly from the environment. Carbamates are used as insecticides, fungicides, and herbicides. Carbol, brand name 7, is used to control garden pests, for example, wasps, hornets, snails, etc., and ticks and fleas on pets. Metam-sodium is one of the most used carbamate pesticides in the U.S. applied as a soil fumigant. Methyl isocyanate, MIC, is used to produce metam-sodium and is also a byproduct of its breakdown. MIC is very toxic to human beings, aquatic organisms, and plants. An accidental release of MIC from a Union Carbide factory in Bhopal, India, in 1984 resulted in more than 3,800 deaths and an estimated 11,000 people injured and disabled. Acetylcholinesterase is an enzyme that normally hydrolyzes acetylcholine to acetic acid and choline. Acetylcholine stimulates nerve fibers. Carbamates inhibit acetylcholinesterase activity, leading to increased acetylcholine stimulation of nerve fibers. Symptoms of carbamate poisoning include confusion, delirium, hallucinations, tremor, seizures, defecation, urination, excessive dilation or constriction of the pupils, mydriasis or meiosis, respectively, bronchospasm with associated wheezing, emesis, lacrimation or watery eyes, salivation, tachycardia, and hypertension. Carbamates rarely cause symptoms more than 24 to 48 hours after exposure and do not cause chronic toxicity. Another group of pesticides is organochlorines, referring to compounds containing chlorine, carbon, and hydrogen. Organochlorines are used as herbicides, insecticides, fungicides, and in many industrial processes. These compounds are stable, fat-soluble, and bioaccumulate. Examples of organochlorine pesticides include DDT, dichlorodiphenyl trichloroethane, lindane, chlordane, Mirex, hexachlorobenzene, and methoxychlor. Other organochlorine monochlorine compounds include industrial chemicals like polychlorinated biphenyls, PCBs, and chlorine compound waste products like dioxin and furans. Let's consider dioxins and DDT for a few minutes. Dioxins are common byproducts of industrial processes. For example, smelting, chlorine bleaching of paper pulp, manufacturing of pesticides, etc., and uncontrolled and incomplete waste incineration. Technology is available to reduce dioxin emissions from incineration. Dioxins can also be produced from natural sources, including volcanic eruptions and forest fires. The environmental distribution of dioxins is global, with the highest levels found in soils, sediments, and food, especially dairy products, meat, fish, and shellfish. Very low levels are found in plants, water, and air. Due to the omnipresence of dioxins, all people have a background level of dioxins in the body. Short-term exposure to dioxins may result in skin lesions, including chloracne and patchy darkening of the skin and altered liver function. Long-term exposure is linked to impairment of the immune system, the developing nervous system, the endocrine system, and reproductive functions. Dioxin has been classified by the WHO International Agency for Research on Cancer, IARC, as a human carcinogen. The developing fetus is most sensitive to dioxin exposure. DDT was used extensively from the 1940s to the 1960s and was effectively used to control malaria, typhus, and other insect-borne diseases, saving millions of lives. DDT is a highly stable compound that persists in the environment for decades. It also bioaccumulates or concentrates as the chemical moves up the food chain. A metabolite of DDT is DDE, diphenyl trichloroethylene, which is formed when DDT is ingested and metabolized, for example, by fish that eat lower aquatic organisms containing DDT. Insects develop increased resistance to DDT over time. Animals and humans, when eating DDT or DDE, concentrate these chemicals in adipose or fat tissues. In humans, DDT has an estimated 10-year half-life, which is the time it takes to clear half of the chemical from the body. All living organisms on Earth contain DDT. Women tend to have more adipose tissue than men and therefore concentrate more DDT or DDE chemicals than men. DDT is not considered a highly toxic chemical, yet it has been associated with a variety of health effects, including increased cancer, for example, pancreatic cancer, Hodgkin's lymphoma, breast cancer, reproductive impacts, including reduced sperm counts, reduced lactation, and impaired neurologic function, for example, irritability, dizziness, numbness, etc. DTT and DDE is associated with an anti-androgen or estrogen effect, which can impact fertility, pregnancy, fetal development, and estrogen-associated cancers. Due to increasing insect resistance to DDT, persistent environmental contamination, and human health concerns, DDT use was banned in the US in 1972. DDT has also been banned in most developed countries, but is still used in the developing world. Since 1972, average body fat concentrations of DDT in the US have declined from 15.6 parts per million in 1956 to 3 parts per million in 1980. although the average fat levels of DDE has remained constant in humans due to the ingestion of DDE containing fish and other foods. Pyrethrin is a natural insecticide derived from chrysanthemum flowers. Pyrethroids are manufactured pyrethrin-like compounds. Pyrethrin interferes with the transmission of insect neural impulses, paralyzing and killing the insect. Some insects may recover from pyrethrin paralysis by using enzymes to detoxify the insecticide. Common pyrethroids include permethrin, biphenyls, cyfluthrin, cypermethrin, and telfluthrin. The most common pyrethroid used is permethrin. Pyrethroids are delivered by a variety of mechanisms, including aerosols, insecticide bombs, pet shampoos, and topical solutions to treat lice and repel mosquitoes. They are highly toxic to a number of beneficial insects like honeybees, fish, and other aquatic organisms. Pyrethroids degrade rapidly in sunlight. Pyrethroids are of low toxicity to humans. The most common adverse effect of skin exposure is paresthesia, or sensations of tingling, burning, prickling, itching, or numbness on or just underneath the skin, presumably due to stimulation of cutaneous sensory nerve fibers. The face is the most common skin area affected. Paresthesia is exacerbated by heat, sunlight, scratching, sweating, or the application of water. Pyrethroid ingestion within minutes may result in sore throat, nausea, vomiting, and abdominal pain. Ingestion may also cause mouth ulcerations, increased secretions, and/or dysphagia or difficulty swallowing. Systemic effects occur within 4 to 48 hours of exposure and may include dizziness, headache, fatigue, palpitations, chest tightness, and blurred vision. This slide provides examples of herbicides and defoliants related to various classes of compounds. We will discuss atrazine, paraquat, and Agent Orange in this session. Atrazine comes from the triazine class of compounds and is one of the most widely used weed killers in the United States and is commonly used to treat field crops like corn. Runoff from rainfall and irrigation carries this herbicide into surface waters. Animal studies suggest that atrazine exposure can cause reduced fetal growth, birth defects, and damage to the liver, kidney, and heart, though these health concerns have not been confirmed in humans. Some studies also suggest that atrazine may be associated with the development of various cancers, though atrazine is not currently considered a carcinogen. Paraquat comes from the biphenyls class of compounds and is commonly used in farming. Paraquat is toxic to humans and is listed as Category 1 for inhalation, Category 2 for ingestion, and Category 3 for skin contact. Paraquat causes severe inflammation of the lungs when inhaled or ingested and can progress to irreversible pulmonary fibrosis, also called paraquat lung, with an estimated mortality rate of 60 to 90%. Paraquat also causes moderate to severe irritation of eyes and skin. Diluted paraquat, used for spraying, is less toxic. Thus, the greatest risk of accidental poisoning is during the mixing and loading of paraquat for use. Let's now discuss Agent Orange for a few minutes. The name comes from the orange strips on shipping barrels of this herbicide. Agent Orange refers to a mixture of herbicides that commonly contain two chemicals used by the U.S. during the Vietnam War in the 1960s to early 1970s as a defoliant of jungle foliage to expose enemy positions. 2,4-D is 2,4-dichlorophenoxyacetic acid, and 2,4,5-T is trichlorophenoxyacetic acid. It's estimated that a significant number of the 1.5 million military personnel who served in Vietnam were exposed to these chemicals. A major health concern for exposure to Agent Orange is cancer. The Institute of Medicine concluded that there is sufficient evidence that Agent Orange exposure is associated with soft tissue sarcoma, non-Hodgkin's lymphoma, Hodgkin's disease, and chronic lymphocytic leukemia. Other health concerns associated with Agent Orange listed by the Department of Veterans Affairs include Parkinson's disease, type 2 diabetes, heart and liver diseases, hypothyroidism, and spina bifida in children of Vietnam veterans. This slide lists a few additional health considerations regarding chemical pesticides. Agricultural workers and their families are at increased risk of pesticide exposures. Pesticides applied to pets to control fleas and ticks can harm and kill pets. Children exposed to pesticide-treated pets are at greater risk of toxicity. Livestock toxicity can occur through contaminated feed or pastures. Pesticide residues can be found in meat, poultry, and dairy products consumed by humans. Pesticides can drift and affect people in proximity to application sites. For example, chloropicrin is a broad-spectrum volatile pesticide that's used as a soil fumigant to control fungi, microbes, and insects. It was developed in 1848 by a Scottish chemist, John Stenhouse, and was used as a poison gas in World War I and also by Russia in the Ukrainian War. Chloropicrin is a common soil fumigant used in California. In 2003, chloropicrin was injected 17 to 18 inches into the soil to treat 34 acres of land in Kern County, California. 165 individuals located within a quarter-mile drift area of the application site experienced irritation of the eyes or respiratory tract, with 5 individuals requiring hospitalization. 7 individuals had persistent symptoms at least 11 days after exposure. Besides chemical pesticides, biopesticides, antimicrobials, pest control devices, and farming practices are used to control pests. Let's discuss biopesticides briefly. A biopesticide is a biological substance obtained from a living organism, for example, plants, bacteria, fungi, parasites, etc., that damages, kills, or repels pests and can be categorized as microbial pesticides, plant-incorporated pesticides, and biochemical pesticides. An example of a microbial pesticide is Bacillus thuringiensis. Bacillus thuringiensis, BT, produces an endotoxin-like cry protein that, when ingested by susceptible insect pests, attaches to specific receptors in the midgut, creating holes and killing the pest. Humans and animals lack these receptors and are therefore not susceptible to these cry proteins. Not all insects have these receptors in their midgut. Plant-incorporated protectants are pesticidal substances produced by plants to control pests. For example, scientists can introduce the Bacillus thuringiensis BT pesticidal gene into a plant's genetic material, creating a genetically modified plant that produces Bt cry proteins that kill susceptible pests when they feed on the plant. Biochemical pesticides are naturally occurring substances that control pests through non-toxic mechanisms. Examples of biochemical pesticides include sex pheromones that interfere with insect mating and scented plant extracts that attract pests to traps. Let's spend a few minutes discussing polychlorinated biphenyls, or PCBs. PCBs are a large group of organochlorines associated with industrial processes. They are also classified as dioxin-like chemicals. Aerochlor, ascarel, and thermanol are examples of common PCB trade names. PCBs are chemically stable, have low flammability, are inexpensive to produce, and have good insulating properties. Common uses of PCBs include insulating fluids in transformers and capacitors and use as a lubricant. Leakage of PCBs from transformers contaminates the environment. Due to their chemical stability and slow process of degradation, PCBs may remain in contaminated sites for decades. PCBs bioaccumulate in fish and other animals that are used for human food. PCBs are included as toxic agents in almost 1/3 of the EPA's National Priorities List. As previously mentioned, the National Priorities List, NPL, is a roster of sites across the United States and its territories that are considered national priorities due to known or threatened releases of hazardous substances, pollutants, or contaminants. The Environmental Protection Agency, EPA, uses the NPL to guide further investigations and determine which sites require remedial action through the Superfund Amendments and Reauthorization Act, SARA. The manufacture of PCBs was banned in the U.S. in 1977. Occupational exposure to PCBs can result in a broad spectrum of effects that includes liver damage, skin rashes, and respiratory problems. Other potential adverse human health effects include abnormal fetal development and reproductive, thyroid, cardiovascular, gastrointestinal, genetics, immune, musculoskeletal, and neurological systems problems. Based on sufficient evidence of carcinogenicity in humans and experimental animals, the International Agency for Research on Cancer, IARC, classified PCBs as a Group 1 carcinogen for humans. Group 1 substances in the IARC classification system means that the substance is carcinogenic. Group 2A is probably carcinogenic. Group 2B is possibly carcinogenic. Group 3 is not classifiable. Group 4 is probably not carcinogenic. A solvent is a substance, usually a liquid, that dissolves another substance. People are generally exposed to solvents through inhalation, ingestion, or skin contact. Industrial facilities may release solvent vapors into surrounding communities. Solvents may enter soil and groundwater through improper disposal of solvent-containing products. Most, but not all solvents do not persist in the environment since they are generally highly volatile. There are many organic solvents. This session will briefly discuss 6: tetrachloroethylene, trichloroethane, trichloroethylene, toluene, acetone, and benzene. Tetrachloroethylene is a synthetic non-flammable solvent. and is used in the dry cleaning industry and as a metal degreaser. Health impacts include neurologic effects on consciousness and death with high-level exposures. In animal studies, high-level exposures are associated with kidney and liver cancer. The International Agency for Research on Cancer, IARC, states there is sufficient evidence to designate tetrachloroethylene as carcinogenic in animals, with limited evidence in humans. Trichloroethane has two forms, 1,1,1-trichloroethane and 1,1,2-trichloroethane. The 1,1,1-trichloroethane form is used in degreasing compounds and household cleaners. Health impacts vary with the level of exposure and include dizziness and loss of consciousness. The 1,1,2 form is generally used in the production of other chemicals. It is stable in the environment and may persist as a contaminant of groundwater. Skin contact can produce local irritation and skin rashes. Trichloroethylene, TCE, is highly volatile and is used as a degreaser and component of cleaning agents, paint removers, and adhesives. Trichloroethylene, like 1,1,2-trichloroethane, is stable in the environment and may persist as a contaminant of groundwater. Low-level exposures may result in dizziness and headaches. Inhalation or ingestion can cause unconsciousness and death. Some epidemiologic studies have reported an increased risk of cancers of the kidney, cervix, liver, and biliary passages, non-Hodgkin lymphoma, and esophageal adenocarcinoma. The manufacture of trichloroethylene in the U.S. was discontinued in 2002 due to its potential impact on the ozone layer. Toluene is found in nail polish, paints, and adhesives. Low-level exposures are associated with reversible neurologic effects. High-level exposures may cause unconsciousness and death. Toluene exposure may cause renal or kidney damage. Acetone is highly volatile, flammable, and dissolves in water. Acetone is found in nail polish, a variety of cleaners, and paints. Moderate exposure can result in irritation of the eyes and respiratory system. High levels of exposure are associated with headaches, vomiting, and unconsciousness. Benzene is a volatile liquid used to produce plastics, resins, and synthetic fibers. It's also used as a solvent for wax, paints, resins, oils, plastics, and rubber, and is a component of fuels, for example, gasoline and crude oil. Cigarette smoke contains benzene. Moderate exposure can cause central nervous system depression and can damage blood and blood-forming organs. High levels of exposure can be fatal. Benzene is a known IARC Group 1 carcinogen associated with acute myelogenous leukemia. Exposure to solvents during pregnancy has been linked with spontaneous abortion. There are multiple chemicals used in the manufacture of plastics. For this session, we will briefly focus on four: styrene, vinyl chloride, phthalates, and bisphenol A, or BPA. Styrene is used in the production of plastic packaging materials, disposable drinking cups, and insulation. Health impacts include central nervous system signs and symptoms of muscle weakness and difficulty concentrating. Irritation of the respiratory system can also occur. The IARC lists styrene as a possible carcinogen, group 2B. Vinyl chloride is highly volatile and flammable and is used primarily in the production of polyvinyl chloride, which is used in the manufacture of pipes, vinyl siding, plastic coatings, and upholstery. Health impacts from exposure include nerve and immune damage, reduced circulation of the upper extremities, and damage to the distal digital bones. Vinyl chloride is classified as a carcinogen, IARC Group 1, associated with angiosarcoma of the liver. Phthalates are plasticizers or substances that increase the softness and pliability of plastics used in their production of automobile components, food packaging, toothbrushes, toys, nail polish, and additives for cosmetics, aspirin, and insecticides. Health impacts include a potential anti-androgenic effect or suppression of male sex hormones. Phthalates are released into food and water packaged in plastics containing phthalates. The U.S. banned phthalate use in the production of children's toys and childcare products in 2007 out of concern about potential health risks. Di-2-ethylhexyl phthalate, DEHP, is used in medical products including intravenous and blood containers, plastic IV tubing, and gloves, and is considered safe. The ATSDR states that at the levels found in the environment, DEHP is not expected to cause harmful health effects in humans. Bisphenol A, BPA, is widely used in their production of plastics and resins used in packaging food and water, baby bottles, compact discs, impact-resistant safety equipment, polycarbonate tableware, and medical devices. BPA can leach into container contents. Human exposure to BPA commonly comes through ingestion. Though the impact on human health is not known, animal studies have demonstrated reproductive and fetal development effects. In summary, hazardous chemicals are necessary for modern life, but are also a potential health risk globally. It's estimated that each dollar invested in pesticide control returns approximately $4 in crops saved. Due to the omnipresence of dioxins, all people have a background level of dioxins in the body. All living organisms on Earth contain DDT. Pyrethroids are of low toxicity to humans. Atrazine is one of the most widely used weed killers in the United States. Polychlorinated biphenyls, benzene, and vinyl chloride are group 1 carcinogens for humans. 1,12-trichloroethane and trichloroethylene are stable in the environment and may persist as a contaminant of groundwater.